Hi friends, my name is Tris. I was a Python web developer for 15 years before discovering Rust, but these days I think it's easiest to say that I am a professional writer. I write code, music, and fiction and non-fiction prose. 3 years ago, I accidentally monetized my addictions into a YouTube channel called No Boilerplate, where I talk about Rust and my various other technical hyperfixations. I'm a Linux guy, still have my Ubuntu 6.06 CD. I even worked at Canonical for a few years, but these days I use Nixos. Please excuse the name change. I found while I wrote the talk that although there was a lot I want to say about const, there was even more I wanted to talk about with macros. Perhaps I should have called it compiletime crimes, but Amos and James already did that a few months ago. I only listened to the episode 2 days ago. I wish I'd listened to it earlier. Today I'm going to talk about Rust's compile time, outside the focus of type correctness and safety, which gets all the press. This is a topic that is underserved in our community, I believe, because it's such an alien idea, except for Lisp programmers. And yet it's so cool. I believe there's a whole world some folks might be missing. I live at compile time. I love pushing as much logic from runtime to compile time using Rust's rich type system. Lifetimes allow me to model not just what my data is, but when. I'm never happier than modeling my data with the rich type system. However, cruel external forces keep asking me to actually get some work done. Runtime is a very scary world of threads, asynchronous databases, and worst of all, users. Before we start, some housekeeping. I dedicate all my work to the public domain, and this talk is no different. If you are listening to the recording of this talk and find that I speak too fast and you'd like to read along, you may read this script at my site, namtal.com. If you're listening to my voice live in the room, please give me a few hours to upload it. Everything you see in here today was written by me, a human, just like you. I can tell you have burning questions already. Fine, we'll be quick. Thanks, bow ties are cool, but not a question. The skinny font is Yosevka. The tonal presentation software is Presenterm, written in Rust. You're seeing images and variable height fonts thanks to Kitty. I'm exploring WesTerm and Rio, don't at me. And no, you've not seen me on YouTube. You can see me now, unfortunately. You might recognize my name from my extremely important contribution to Rustlings 2 years ago. That's what I'm most known for, I believe. Okay, here's what we're talking about today. Introducing the const world, a cozy subset of Rust where computation can be done without executing any runtime code. Then acknowledging that unreasonable forces may ask you to produce more side effects than just heating up your laptop. Silence these criticisms with macros. And then working out what we can and can't do with our newfound superpowers. And finally, a look at the absolute state of the art. I'm a native of cyberspace, and therefore scared of interacting with other humans directly. Therefore, there will be strictly no audience participation during this talk. I feel I am among friends, though, so I will start with sharing an extremely brave opinion with you today. Rust is good. Nearly every feature that I wished for over the course of my career as a senior developer, Rust has. And now that I exclusively write Rust, every day I find that the language seems to have predicted the features I need before I know that I need them. It's no secret how this happened. It is thanks to the skill, expertise, and foresight of the genius maintainers and community, many of whom are here today. Rust feels to me a little bit like it was designed backwards, looking at existing solutions and learning from all the mistakes of the past. Whether it's the most popular languages in the world and Clojure, realizing a little too late that static typing is enormously helpful in building our complex systems, or Java's attempt to fix the billion-dollar mistake of nulls. Oh, I mean Groovy. No, Scala, Kotlin. Just one more language, bro. I swear we'll fix it next time. And don't get me started on Python's package managing. Before Rust, I wrote Python for 15 years, and every time a junior developer asked me to explain the virtual end situation, I died a little inside. Rust brought me back to life. Metaprogramming is nearly always left out or nerfed in programming languages because of how misused it has been in the past. Template Haskell is legendary. C and C++ have evolved multiple layers of preprocessors, and even Zig's otherwise very good comp time is severely limited because they're scared of arbitrary code execution. I am not scared of executing arbitrary code at compile time, and neither should you. In fact, I'm quite excited by it, and I discovered it almost by accident. Oh, we got some jokes. There are only two hard problems in distributed computing: correct ordering of messages, exact once delivery, and correct ordering of messages. Let's look at this simple Rust function. It may be elegant and beautiful, but nonetheless clippy, both my wise master and infuriating nemesis, has a problem with it. Can anyone see what is wrong here? What is wrong is you've forgotten that there's no audience participation in this talk. If you set up Clippy to neg your code by erroring on pedantic lints, which is what I do because I love pain, this simple Rust function will not compile. A quick aside on how much I love the combination of bacon and Clippy. Rust Analyzer is certainly incredible. However, LSP is inherently line-based, and you will read the warnings and errors out of compiler order and in the order of lines in your file. This is often what you want, but not always. And it doesn't quite have the same teaching power as the raw output from Cargo Clippy. Compare this inline error with Clippy, which is set up with the pedantic lints I just showed you. The compiler's output isn't just beautiful, it nearly always comes with hints to what you should fix. If you run Bacon Clippy in a terminal while you work on your project, you will find, as I did, that it can teach you Rust, as happened with my const journey. This error here was my first clue hinting at Rust's secret world. Clippy tells us that this function could be a const function. And if you've scoped your functions tightly and hygienically controlled for mutation, you may find Clippy tells you this about some of your functions too. By the way, the fix, as ever, is to do what Clippy tells you to do. Obey the compiler and turn the function into a const function. Const functions are functions that are safe to execute in a const context at compile time. They differ from Rust macros by being much more limited in their side effects. For example, not all floating point operations in the standard library are supported, compared to their int counterparts. And this is due with the side effect that your CPU, from the code's point of view, might be affected by side effects during the floating point operations. Change the target, change the floating point hardware, and you could get a different output for the same input. If you think about it, const functions aren't weird for disallowing floating point operations like this. It's the rest of us who are weird for assuming floats work. Just like with pure functions and functional languages, these limits on const functions make them exciting. Const functions have access to a limited subset of Rust. You could read about it in the reference, but let's experiment because it's more fun. Present term, by the way, runs all my code blocks through the compiler. It ran this just now, and it compiles, so it's obvious that a lot works in const functions. Side note, I'd like to take a moment to publicly shout out Matthias Fontanini for making present term and responding to all my unreasonable feature requests over the last 6 months. I was literally editing my presentation 1 hour ago just to take advantage of new features he had added to present term. Tip your open source software developers, folks. It's obvious that a lot works in the strict environment of const functions, including, from top to bottom, arithmetic operators, tuple indexing, array slicing, structs, non-capturing closure expressions, shared borrows without interior mutability, safe casting, calling other const functions, loop, while, let, if let, and match, and range expressions. Quite a lot, but it's not everything. And some of what works is qualified. By the way, if you're curious, the const crate has const equivalents of many functions that are in the process of being made const compatible in the standard library. More on that later. I don't have time today to talk about Rust's granular purity system that const kind of gives you. Those who are interested may watch my video on this topic. Because while const functions are cool, there are some problems we as engineers are trying to solve for which compile time side effects are a feature, not a bug. For them, you'll need access to the whole language, not just the sanitized subset available in const context. And just like with the escape hatch of unsafe, macros are the escape hatch of const. Part 2, macros. Macros execute arbitrary code at compile time and then can insert the result of that processing as potentially const values, like here, the result of interrogating the path is a const static string. I understand they can rewrite syntax as well, but that's not what I'm talking about today. Arbitrary code execution, while compiling, is an extremely clever trick that Lisp figured out in the 1950s. Are there any Lisp programmers in here today? Anyone written Lisp for bonus points? Anyone been paid to write Lisp for 2 years at a bank? Can't believe they did that. Anyone? Okay. Come find me afterwards, obviously. You are not sufficiently excited about macros. This unassuming example is wild when you think about it. JavaScript can't do this, nor can Java, Ruby, Go, or any of the top 20 languages by Stack Overflow tags and GitHub projects. In all these other languages, The source files are effectively dead text until the end user calls them to wake them up. Everyone clear? You can rewrite syntax and have your function call at runtime, or you can run the code during compilation right now. Part 3. What can we do? Having a macro system that can rewrite syntax at compile time is already incredible. And in Rust, this basic feature is even more powerful than you can find in other languages, which limit you to only valid language syntax. This allows you in Rust to build DSLs with almost no restrictions, such as one of my favorites, the macro Lisp crate. It's not a Lisp when it gets to runtime. This syntax with all our ancestors' parentheses in is rewritten at compile time into a valid Rust function. And this is not some kind of toy or hack. The errors work so well. The crate effectively teaches the Rust compiler to speak Lisp using the macro system. Thanks to the incredible work of the Rust Analyzer team, thanks, Lucas, macro errors work even in editor at nearly always the right line number. But the power is much more than rewriting code or reducing boilerplate, though you better believe I love that feature. You can do anything in a macro. There is no compiler police like there is with those Puritan const functions to tell you what you can and can't do. Want to execute code that has nothing to do with the eventual syntax you will insert into the source code? Do it. Joke the second. There are only 2 hard problems in computer science: cache invalidation, naming things on off-by-1 errors. This secret compile time world is inaccessible to most other languages for technical reasons, but it is also inaccessible to most Rust developers for non-technical reasons. It happens even to the best of us. Thank you, Horatio, for letting me use your demo code as an example. This was my favorite talk from yesterday. This is completely understandable, to forget that you can reduce boilerplate with macros. It is perhaps a problem of hermeneutics, unknown, or what we in the programming community call the blub paradox. This paradox is where people who have learned a lower-level language can't imagine why they would need the features of a higher-level one. Paul Graham said that programming languages are not technologies, but habits of mind. Lisp might be the best language for your project technically, but try changing a Python team's mind about writing it all in Python. Programmers are, on the whole, a practical guild. We are interested in solving problems with the magic lightning that we've persuaded a rock to think with. You can solve all problems with a simple Turing machine and a few for loops and if statements, but if you're using Rust, you have access to macros at compile time. Tell the Python developer that, and they'll be nonplussed. They've never needed. They solve their problems with duck typing, debugging in production, and iterators. Iterators, says the C programmer? What's wrong with a for loop? Functions, says the basic programmer. Gotos have worked fine for years. Gotos, says the assembly programmer, just stick some bytes in memory and jump there. And of course, we know real programmers use butterflies. In Rust, unlike with Zig, unlike with C or Haskell templates, the whole language is available at compile time. This was one of the key breakthroughs with Lisp 70 years ago, and yet most implementers are afraid to add this functionality to their language. There is no need for this fear. We've had 70 years to solve the problems and build good rules, rules such as never do in a macro what you can do in a function. This wisdom is passed down from the old Lisp masters, if only we can hear it. Joke the third. We only have 2 problems in all of software engineering. We've only got 1 joke, and it's not very funny. Look, every other top 20 language doesn't allow us this power because they're afraid. Powerful tools have powerful features, and you can cut yourself with them, but that doesn't mean you should be afraid of them. Story time. About 10 years ago, I was a member of a community workshop that had tools, machines, and a nice atmosphere all available for us to use. Some of the machines, like the laser cutter, were delicate and had instructions printed on posters on how to use it without damaging the sensitive components. But there was one machine that had no instructions on how to use. The lathe. Instead of diagrams and descriptions of safe use, the lathe had a sign hung over it, stating simply, "This machine wants to kill you." The takeaway wasn't to not use the machine, but be fucking careful. Can you do crimes with Rust macros? Yes, of course. We will return to those later. Whether neither I nor the compiler nor God can stop you from spawning threads during compilation. I'll remind you that the whole language is available, network and all. But this is good. Look at what they need to mimic a fraction of our power. Every language ends up requiring compile-time macros that have full access to the underlying system. But because they don't build them in from the start, they must create, to misquote Greenspun's 10th rule, an ad hoc, informally specified, bug-ridden, slow implementation of half of a macro system. This is just another example of the Rust community truly understanding what features you need in a language, macros, and what features you don't, garbage collection. And before you speak, I can already hear you ask, aren't there any security considerations with arbitrary compile-time code execution? And to that I say, shut up. Don't worry about it. You're not my real mum. I'm not on trial here. I said no questions. But fine, sure, we'll talk about it. You may have, as I did, read this post on Hacker News 2 years ago, where Eric built a proof of concept macro that deleted a user's SSH key if they compiled, not ran, the project. In his blog post, he said that the Rust team and ecosystem will need to work to release fixes and security enhancements to prevent arbitrary code execution vulnerabilities like this one in the future. Eric, we're actually good here, thanks. Thank you for your concern. Firstly, only allowing arbitrary code execution at runtime isn't the solution that everyone thinks it is. You know what I do right after I compile my code? I run my code. Secondly, the problem is already fixed. In VS Code, the editor for babies who are afraid of the command line, I'm kidding. Not really kidding. But there is a much more important reason why I don't care about imagined macro security problems raised by people who have never used a language with them in. And it's this. The thing with computer programs is they get to program the computer. I feel like we lose track of this when talking about macros. But what if my program executes bad code? I don't know. What if it executes good code? Be nice. Every build system needs to run arbitrary code. Rust just made it first class. I know which one I prefer. OK, part 6, the absolute state of the art. How are we doing for time? Great. To finish up, I've got a speed run of cool crates, starting with the popular SQLX. If you can access the network at compile time, that means you can access your local dev database and throw some strings at it and double-check your SQL syntax works before you even run a single thing. God, I love a SQLX. Const random. You can run random number generation at runtime if you really want. By the way, I've got a slightly different version of that if everyone wants to use it. No dependencies required. I don't know where I found that one, but that's a good hack. But you do have to recompile to get a second number. Compiletime, very similar to Zig's version. And const time, slightly different spelling, does the same thing. Arbitrary code execution, just in a nice simple block. Const time, lazy stack. Let's get this worked out here. Lazy static defers until runtime what you want, whereas const time is running it immediately at compile time. Compile time run, if you just want to run some random programs, easy. That's how to do it. This is where I would have my crab time demo if I had one. It is currently broken, and I couldn't get it to work on my machine. Crab time is the most mature-ish looking, but there was some tweaks that they need to make. Now, I said I'd return to this in a moment. Is Mara here? Damn shame she's not. OK, right, well, good. We can talk about this finally. So, you can inline Python with her crate. I'm not sure you necessarily should, though if you want NumPy, SciPy, you can get it nice and easy. You can use her addition crate to randomly select arbitrary additions to run code inside of. And of course, whichever compiles. At least she has some shame about this one. I'm showing you these not just as a way of retribution against Mara, but to show you can just do anything. Anything you like, have a think about it. I've presented this evidence because she can't keep getting away with this. And lastly, some crates I found during my research that have cool names. Nikolai Vasquez Constantine, Roman's Evalanche, and Sayan Nadan's Constant. Just a good name, don't worry about it. That's it. Thanks.